Welcome to the Learning Hub once again. In today's video, we are going to talk about mole concept. Particularly, we are going to look at the calculation aspect of it. And this calculation or this concept is going to help you remember every calculation aspect as far as the mole concept is concerned. So let's set the ball rolling. In everyday life, we used to apply collective terms to describe a number of objects or entities. For example, when we say a cent is made up of 100 entities. A gross is made up of 114 items. And when we say a dozen is made up of 12 entities. In the same scenario, in chemistry, mole. The term mole is used to describe a quantity of material made up of 6.02 times 10 exponent 23. So that's what we are going to talk about. So when we say a mole, it means that 1 mole is equivalent to 6.02 times 10 exponent 23 particles. These particles can be ions, it can be atoms, as well as molecules. Make sure you subscribe to this channel so that you would get updated on all these particles. It has already been explained in our previous videos. Or subscribe to this channel so that you get updated always. So when we say a mole which is 1 is equivalent to this. So which means that when I take 2 moles, it will be equivalent to 2 times this 6.02 times 10 exponent 23. And it goes on. 3 moles, it will multiply by this. 3 multiplied by this. 4 multiplied by this. That's what we mean by mole. Now, mole is a basic quantity. We have 2 types of physical quantities. We have basic quantities and derived quantities. The basic quantities, there are 7. We normally use an acronym for all these 7, which is L, A, M, T, T, E, L. So the first one is the length. Let me use different color. Length. The next one is amount of substance. The next one is mass. The third one is time, temperature, electric current, luminous intensity. So if you want to remember the basic quantities, so these are called the basic quantities. So if you want to remember the basic quantities, you will just use LAMTEL. There are 7 of them. We have the length, amount of substance, mass, time, temperature, electric current, luminous intensity. So what we are looking at here is the amount of substance, which is the mole. What do we mean by mole? Mole is the amount of substance that contains the Avogadro's number of particles. So mole is the amount of substance that contains the Avogadro's number of particles. In other definition, we can say that mole is the amount of substance that contains as many elementary entities as there are carbon atoms in 12 grams of carbon-12. And I know that most of us would like simple ways of learning. So simply put, mole is the amount of substance that contains the Avogadro's number of particles. This is a popular question that normally comes to our WASI as well as our NOVDEC. We will also look at molar mass. As I said, we are going to look at the calculation aspect of this concept. The next one is molar mass. Molar mass is the mass of 1 mole of a substance. So it's this way, M into brackets G over. So when they ask you what is molar mass is the mass of 1 mole of a substance. Molar mass is the mass of 1 mole of a substance. Take note. So you can use the formula to define whatever you want. So if you write the formula somewhere, you just write the definition. If the molar mass, big M, is equal to the mass over mole. This one is in grams, this one is in mole, so N. It means that when I take 1 mole, I have a particular mass. If I ask you to calculate the molar mass of the following, say glucose, the formula, the chemical formula for glucose is C6H12O6. Now, the relative atomic masses will be given to you. C is given as 12, hydrogen is given as 1, oxygen is given as 16. So if I ask you to calculate the molar mass of this, it's simply you multiply the number of atoms here, carbon atoms, which is 6. So 6 multiplied by the relative atomic masses, which is 12. So we have hydrogen 12 times the number the relative atomic mass, which is 1, plus oxygen, which is 16 multiplied by 6. When you add everything, you get 108 grams per mole. As you can see, grams per mole. So molar mass is the mass of 1 mole of a substance. So what this means is that when I take 1 mole of glucose, 6H12O6, I will have a mass of 108 grams. So another example is 2, sodium chloride. This is very popular. Sodium chloride. The relative atomic mass for sodium Na is equal to 23. Cl is 35.5. So if I am to calculate the molar mass, I have the number of atoms of sodium is what? 1. As you can see, the number of atoms of sodium is 1. So I have 23 times 1 plus the number of atoms of chlorine here is just 1. So I have 35.5 times 1. Remember, I multiply the relative atomic masses by the number of atoms. So when I multiply this, I get 23 plus 35.5, which is equivalent to, when I add this, I get 8.5, then 3 plus this, I get 58. So 58.5 grams per mole. So this also means that when I take 1 mole of sodium chloride, I have this mass. So when they are asked to calculate the molar mass, you just multiply the number of atoms over here by the relative atomic mass, which will be given to you. The next formula I would like you to look at is number of moles is equal to concentration times volume. The moles to bracket N is equal to concentration multiplied by the volume. The concentration here we are looking at is the molar concentration, and it's always in mole per dm cube, and this one is always in dm cube. So it's either you see it mole per dm cube or you see it to be molar, capital M. So in order to check if you are correct, we know that number of moles is equal to concentration times volume, which is mole per dm cube multiplied by dm cube. it means that this and this cancels. So the number of moles has an SI unit of what? MOL. I hope you are convinced with this. The concentration here is molar concentration. Then the volume also has to be in what? dm cube. What it means is that when you are given in cm cube, so let's say 500 cm cube, what you have to do is to divide by 1000 cm cube, so that you get what? 0.5 dm cube. When you are given 20 cm cube, you divide by what? 1000, so that you move 1 2 1 2, so you get 0.02 dm cube. Don't be confused with how I moved. You can punch on the calculator and you get the same answer. Our next is mass concentration. This place, the elective chemistry people should be very vigilant with this. Mass concentration. When you are doing simple titration, you may encounter this particular formula. Mass concentration is similar to density. Density is the mass per unit volume of a substance. So if I say density, which is denoted as rho, before I come back to this, density is equal to mass over volume. This is a Greek symbol known as rho. Density is equal to mass over volume. So you realize that this is kilogram, this is what? Meter cube. So you get it as a kilogram per meter cube. So we are going to use this similar analogy over here. So mass concentration, the name suggests its meaning. Mathematically, it's equal to the mass of solute that dissolves in a particular volume of solution. So we write volume. Mass concentration is the mass of solute dissolved in 1 dm cube of solution. So the mass is always given as grams over the volume, which is what? dm cube. So you realize that the mass concentration has an SI unit of grams per dm cube. So when they ask you what is mass concentration, you simply say that it's the mass of a solute that dissolves in a given volume of solution. Or you say that mass concentration is the mass of solute that dissolves in 1 dm cube of solution. So you can say the mass in 1 dm cube. As discussed earlier, mole is the amount of substance that contains Avogadro's number of particles. What this means is that there is a relationship between the amount of substance, which is the mole, the Avogadro's number, and the number of particles. How is the relationship expressed? The relationship is denoted by N is equal to small n multiplying L. So you can see that this can be Nelson, starting with a small letter, Nelson. Now, here we have the number of particles. The particles, as I said, it can be what? Ions, it can be atoms, it can be what? Molecules. So the number of particles is equal to the number of moles. So this is the what? Moles. And then multiply by what? Avogadro's number. Don't forget, Avogadro is a name, it's a scientist. Okay, it's a scientist. So the number of particles is equal to the number of moles multiplied by what? Avogadro's number. So this formula should be very, very well understood. Don't confuse yourself. The big N is equal to what? Small n over multiplied by capital L. That's Avogadro's number. Avogadro's number will always be given to you, so take note. Our next expression would be the dilution. Dilution in everyday life, we encounter it mostly when you wake up in the morning. What you drink, especially the tea you drink. Some of us, we want our tea to be at the brim of the cup, so you realize that it's always encountered. Some of us, we want it half filled. Some of us, because of greediness, we want it to the brim. So dilution is encountered in everyday life, irrespective of where you find yourself. What do we mean by dilution? A dilution of a solution is the addition of solvent to the solution. What do we mean by that? We are going to look at the mathematical expression, but before that, let's look at these analogies to be able to appreciate it very well. Assuming we have a measuring cylinder. This is our measuring cylinder. Then we fill the measuring cylinder to a particular volume, say 10 centimeter cube. 10 centimeter cube. So this one is centimeter cube. So let me cancel it. 10 centimeter cube. The concentration here is 2.0 molar. That's our concentration. Now we want to increase the volume. We dilute it. We add additional volume. Add another solvent. So we increase the volume to a particular what? So we increase the volume to 20. So let's say we add additional 10. So we had what? 20 centimeter what? Cube. So we have an initial concentration and the initial volume. And then the concentration after adding the additional solvent or water, we don't know. So we only know this one. So we realize that the initial concentration is always denoted as what? C1, which is equivalent to 2.0 molar or mole per dm cube. Then V1 is also given. Before we dilute it, we had a particular volume, which is what? 10 cm cube. Then we have this one too. After adding the volume, we don't know the concentration, so C1 is equal to unknown. And then V1, V2. So this one is C2. This one is what? C2, which is equal to what? 20 cm cube. So what will be the concentration after dilution? So this one you can make it simple by your own self. You have a tea. You woke up in the morning, they prepared tea for you, and then you realize that the volume is too small. You realize your tea is too small. So you want to add more this thing. The tea has an initial concentration which is 2. So you realize that it was sweet and you want more. So you added additional 10 centimeter cube volume of water. So to make it plenty so that you'll be satisfied. It's only some people that want their tea to the brim of the cup. So we add additional volume. So 10 to this, so making 20. So from 10 to this place, we get what? 20. So it means that we have added additional 10. So we have what? So 20. And we want a particular volume. So in simple terms, you realize that after adding the new volume or water, it wouldn't be sweet again. It wouldn't be sweet. So it means that the concentration has what? Reduced. The concentration was reduced. So how do we express this? Initial concentration, it was sweet, so it was 2. So what would be the final concentration after adding this? This is the mathematical expression. So we write C1 V1 is equal to C2 V2. This is it. Or you can use a seconc Vconc is equal to CDU VDU. It means that concentration of the concentrated solution multiplied by volume of the concentrated solution is equal to concentration of the diluted solution multiplied by volume of the diluted solution. Or you can use CIVI is equal to CFVF. It means that concentration of the initial solution multiplied by volume of the initial solution is equal to concentration of the final solution multiplied by volume of the final solution. Either of these formulas, you get the answer correct. I know people would like this, so I'll conform to this. So C1 V1 is equal to C2 V2. C1 initial concentration is 2 multiplied by volume, which is 10, is equal to C2, we don't know the final concentration, multiplied by 20. So making C2 the subject, you divide through by 20, divide through by 20. This cancels this. So we have C2 is equal to 2 times 10 divided by 20. So this will cancel this. This will cancel this. We have what? 1.0 mole per dm cube, which is the same as 1 molar C2. So look at this over here, and then look at this. Which one do you think is higher? It's obviously this. Means that the tea was sweet, but since you want more water, the concentration, the sweetness will decrease. So it is not sweet again. So you taste and your face will change. So you realize that this will be the concentration after dilution. So when you dilute, you decrease the concentration. But when we dilute, what does not change here is this. Take note of this. And this, it comes to your exams always. Section A, they will ask you that what does not change upon dilution? What does not change upon dilution? What does not change upon dilution is the number of moles. The number of moles. It means that when I take salt and I add salt to this, to a particular volume, it's the same salt that is in the beaker or the measuring cylinder. If I add another water, the salt is the same thing. It does not change. If I add water, plenty water, it does not change. It's only the concentration that changes. So take note of this. So this is what we mean by dilution. Irrespective of the question, you should be able to calculate it. So in dilution question, most of the time, you'll be given 3 parameters, 1, 2, probably 3. Then you'll be asked to find this. So it's very simple for you to understand with this analogy. Our next formula is the combination of molar mass, capital M, is equal to mass over number of moles. You can see molar mass is the mass. So as m, small m coming down, one of the leg was broken, so it turned to one leg. So molar mass is the mass over mole. And we also know that number of moles is equal to concentration times volume. Alright? Number of moles is equal to concentration times volume. We have N here, we have N here. So let's say equation 1, equation 2. So it means that when I make N the subject, in this example, you realize that from equation 1, from 1, I can make N the subject. So realize that N will be equal to small m over big M. So now equation, we have equation 3. So you realize that 2 and 3 are equal. So I can say that 2 is equal to 3. So I'll have C times V. So equation 2, C times V, this one, is equal to what? 3, which is what? M over M. So making M the subject, I'll have M is equal to concentration times what? Volume times M. This is a very important formula you would have to what? Remember. So if I want to calculate mass, when I'm given the concentration, I'm given the volume, and I'm given the what? Molar mass. This is what I do. So this one is the concentration, this is the volume, and this is the what? Molar mass. So you have what? So after calculation or putting all the parameters into the formula, you would have the mass equals a particular value, let's say 10 grams. Now, combining all these formulas from the first part, we have one, say molar mass, or so molar mass is equal to the mass of what? Over the number of moles. 2, we know that number of particles is equal to number of moles times what? Avogadro's number. 3, we also have number of moles is equal to concentration times volume. 4, you can also have mass is equal to concentration times volume times what? Molar mass. 5, you can say that C1V1 is equal to C2V2. So you can call this one, as we said earlier, Seconc Viconc is equal to Cidel Videl, or CIVI is equal to CFVF. So these are the formulas you would need as far as mole calculation are concerned. So knowing these 5 major formulas, there is no calculation questions under mole concept you wouldn't be able to answer. So keep on revising this. In our next video, we will take some examples in the past questions, or at your own time, take the past question using these formulas, practice them. You realize that the sweetness of the pudding is always in the eating. Thank you, and I'll see you in our next video.